So for this video, it's a version of the website question, and it's if you go watch my earlier video, I've got the one from the textbook. I think it's number 11 on in chapter 7 of the problem set. And what does a confidence interval do? Well, a confidence interval is going to help us to estimate the mean weight for all Chinook salmon in the Columbia River. We can't possibly catch all the Chinook salmon in the river to find and weigh them and find the average weight, so we use a sample and make inference based on that sample to um, make an estimate of what that population mean is. It's unknown. We're going to use confidence intervals to be able to make it. It really makes a really accurate estimate as long as we have a good sample. So what's the point estimate for the mean weight of all Chinook salmon? Well, our sample of 26 salmon yielded that for sample mean, and that's the best we can do at this point. That's our point estimate. It's at one point in time, we collected that average, that's what we do. Now we're going to do a better estimate by creating a confidence interval. So we know there's some wiggle room. Go out and do another 26 salmon, we're going to get a different mean. We want to come up with an estimate that'll capture 95% of all possible means, and in that, we'll have a good estimate of what the population mean is, right? There's only a 5% chance we'll miss the true mean. So point estimate's the sample mean. If it's a proportion, that's your point estimate. Now to come up with the interval, like I said, that other video walks you through all the how-to, the nitty-gritty of the tables. I'm gonna focus with the Rossman chance applet for this. How do we find the Rossman chance applet? Well, in Canvas, if you click on modules and click on course resources, and then this online statistical tools pops up this page, and this is the one that'll work for t-test, t-intervals, t-tests next week, and proportions. It won't work for the z-distribution where you know the population standard deviation. That's honestly easier done by hand because you got a little mini table on the other table, and that's good. That helps you understand where they all come from. I mean, there's a calculator you can go find, and I'm not saying you can't use it. I just don't know of a good one. So anyway, so we're going to go out to this applet and click on that Rossman chance applet. So I entered the mean, the number of salmon we caught, the average for that sample of 26, and the sample standard deviation. We don't have to do that central limit theorem standard deviation change here because it does it in the applet. Click calculate, it'll draw this little graph. I'm not quite sure what that graph means. I never really pay attention to it. And we're going to do a confidence interval. We set our level of confidence, and here's our lower limit, here's our upper limit. So what that did is that took the mean plus or minus the margin of error. Remember, the margin of error comes from, in this case, the critical value of t for 95% level of confidence with 25 degrees of freedom, but we don't have to do that here, times the standard deviation, in which case is going to be the 4.7 divided by the square root of 26. And that's where we got the E from. Now, they didn't tell us what the margin of error is, and one of the later things we do is show you how to do that, or want you to do that, and look at the problem in the book, or look at those other posts I made when people asked. But so this is our confidence interval. So between 29 here, let's get a pointer going. Between 29.3-ish, they want one decimal place, so 29.3 pounds to as high as 33.1 pounds. So are we 95% confident the mean weight of all Chinook salmon is greater than 30 pounds? Why or why not? We are not, because 30 pounds is inside our interval. If they had said 25 pounds, then we would be confident because that's below it. If they had said 35 pounds, we would have said no way. In fact, they're probably lower than 35 because 35 is outside our confidence interval. Okay? And then they ask us for this last question, and we'll do that. Recognizing that the sample size is less than 30, remember, the central limit theorem says if you get a sample size of 30 or more, we can do it, but you see how it says the spawning Chinook salmon our weights are normally distributed. So because it's normally distributed, we can use sample sizes smaller than 30 and still come up with a really good estimate. Okay, so I tried to answer what is a confidence interval, what is it good for, and how to do it really easy, and then make some and make some interpretation of it. I hope this helps. You know, give me a yell if not, and please Zoom with me if anybody's stuck. That's what I'm here for. We can run through a lot of different versions. My Up and Math has a bunch of versions this week.